Hi guys, welcome back. Today we are going to be talking about arc lengths. I have two examples for you and they do tie pretty closely together. For my first example, we are going to be taking a look at a circle that has a circumference of 18 pi. So I'm going to go ahead and write circumference. Circumference of the circle is 18 pi. And then we also are going to, or we're also given the information that the central angle is going to be 20 degrees. So central angle is going to be 20 degrees. And so what that would look like here, obviously the circumference is the perimeter, so all the way around the circle, okay? And we're going to just draw in an angle of 20 degrees. Okay, so we're talking about arc length, just like when we were talking about the sector, okay, the area of a sector. We are just looking at a very specific portion of the circle. And so when we're looking at arc length, we're really looking at the piece of the circle that is just looking at where that central angle is, but just the perimeter portion. Okay, so just that part of the circumference, the yellow part of the circumference, that's the piece that we are looking for. Okay, and in order for us to be able to find that, we're going to do something very similar than what we did with the previous section for area of a sector. We're going to come up with a proportion. Okay, and we're going to use what we already know about circles and our given information to come up with what we're looking for, which in this case again is arc length. And so our proportion, which is again two ratios set equal to one another, is going to be the arc length, which is what we are trying to find, over the circumference. Okay, because the arc length is a portion of the circumference. Remember, part over whole, the part is the arc, or arc length, and the whole is the circumference. And then we're going to be setting it equal to the central angle, which is going to be a part of the whole circle angle. So circle angle, which is always going to be 360. So this right here is the proportion that we are going to be looking at. Having said all of this, now we can plug in all the information that we have. We know what the circumference is, it's 18 pi. We know what the central angle is, that's 20 degrees, and the angle of a circle is always 360. So I'm going to go ahead, and we are still trying to find the arc length. But instead of writing circumference, I'm going to be writing 18 pi is equal to, instead of central angle, I'm going to write 20 degrees because that is my central angle, and 360 for my angle of a circle. Okay, I'm going to, just like before, simplify by taking out the zeros. You can also multiply both sides by 18 pi, which works out great because then that cancels out, leaving arc length by itself. Okay, and then I have 2 times 18 pi in the numerator, and then the denominator, I'm just going to break up that 36, which is 2 times 18 as well. So this works out great. The 2's cancel out, the 18's cancel out. So the arc length for this particular problem is just going to be pi. Again, keep in mind the circumference was 18 pi, but if I'm just looking at the piece of the circle that is 20 degrees with a central angle of 20 degrees, this arc length right here is only pi out of the entire circumference. Okay, so that would be the measurement for that. So now for my example 2, I'm actually going to keep everything very much the same in terms of the original problem, except for the angle, the central angle. So again, I'm going to have my circumference be the same, which is of the circle, which is 18 pi. But this time what I'm going to be looking at is the rest of the circle. So I'm going to be taking a look at the central angle of 340 degrees. Okay, so just like before, if I have that 20-degree cutout, if I'm looking for the central angle to be 340 degrees, I'm really looking at not the 20-degree angle, but everything else around. I'm looking for that 340 degrees, which means that the arc length that I'm trying to find is not the 20 degrees like we did in the last problem, but the central angle, the remaining of the circumference. Okay, and I'm going to set it up just like we did before. We are trying to find our arc length, knowing the circumference, which is 18 pi. And now my central angle has changed, so instead of it being 20, it is now going to be 340 degrees. However, the angle, my hole, which is the angle of the circle, is still 360. Okay, I'm going to cancel out my zeros here. And then I'm going to try and simplify some things by multiplying both sides by 18 pi. So my 18 pi's cancel, and I'm left with the arc length is equal to, and I'm going to keep the 34 times the 18 pi, and then look what's going to start to happen here. I am going to now break up the 36 by 2 times 18. 18's cancel, and 2 fits into 34 17 times. So I'm left with 17 pi, which is the measure of your arc length. Now, remember that in the previous example, what we did is we actually figured out that this portion of the circle here was pi. Now, the entire circumference is 18 pi. So if we're taking a look at the rest of it, doesn't it make sense for the remainder to be 17? Because 17 pi plus pi should equal the total circumference, which is indeed 18 pi. So this is kind of two different ways of seeing the maybe same angle but in different ways, and seeing how important it is to be able to know what your central angle is and what it is that you're actually looking at as well. Okay, as always, if you have any questions, please feel free to reach out. Make sure that you are doing your practice, because this is new content for everybody. So reach out, do your practice before you take the quiz. Okay, and I hope you have a wonderful day.